मोहम्मद बिलाल कौन है भाई? हु इज मोहम्मद बिलाल? मोहम्मद बिलाल, if this is not a student, I'm going to remove you from the class. Otherwise, you change your name, please. जी मोहम्मद बिलाल।
मैम दिस इज वासिल, एक्चुअली वो मेरा लैपटॉप खराब हो गया
आप
तो मैं
ऐसा करो, इस आइकन को जहाँ नाम नजर आ रहा है ना, उसको राइट क्लिक करके अपना नाम लिखो।
यस मैम।
वासिल, आप रेडी हो प्रेजेंटेशन के लिए?
यस मैम, आई एम रेडी।
चलें, यू कैन शेयर योर प्रेजेंटेशन।
यस मैम। Is my presentation visible?
Yes, it's visible.
Can I start, ma'am?
वासिल, एक मिनट ठहरो जरा, बाकी बच्चे आ जाए। हाँ,
Okay.
शमशान, आप कैसे हो?
हेलो मैम, गुड मॉर्निंग, अस्सलाम वालेकुम।
वालेकुम सलाम, क्या हाल है?
ठीक है मैम। आप कैसी हैं मैम?
आप कहाँ पे हो?
मैम मैं इस टाइम के लिए नहीं।
आपको नेट का इश्यू तो नहीं है?
नहीं मैम, अभी ठीक है नेट।
ठीक चल रहा है? आपके अब हो रहे एग्जाम्स हो रहे हैं आजकल?
क्विज़ेस हो रहे हैं मैम, असाइनमेंट्स हो रहे हैं और कल जो है मैम सॉलिड स्टेट का प्रेजेंटेशन भी है मैम।
अच्छा, कैसा जा रहा है? ठीक जा रहा है?
अभी तक ठीक जा रहा है।
अच्छा, आपने जो रिक्वेस्ट भेजी थी उसका जवाब आया था आपको?
कौन? उसका नहीं मैम, जवाब नहीं आया। और वो अभी जो है मैम कह रहे हैं कि आपको फिर नेक्स्ट सेमेस्टर में वो करना पड़ेगा। इसके
क्या
लिए
करना पड़ेगा?
वो जो न्यू सेमेस्टर है मैम उसमें मुझे अप्लाई करना पड़ेगा और कह रहे हैं कि अगर 1 मंथ अगर ज़्यादा ना हो तो फिर हम उनको जो एडमिशन नहीं देते हैं। और ये उनकी तरफ से पहले पहले तो जवाब नहीं आया था मैम, लेकिन कल जो है उन्होंने मुझे मेल किया था कि इस तरह आप कर ले। और दूसरा वहाँ पे मैम एक आ रहे हैं जिनको मैं पर्सनली भी जानता हूँ, तो उन्होंने भी कहा था कि इशू ये है कि आपको न्यू जो है सेमेस्टर से आपको अप्लाई करना पड़ेगा।
आपने ये उसमें लिखा था कि आपको प्रॉब्लम हो रही है इंटरनेट की और ऑनलाइन क्लासेस की, और ये मसले जो आपके एग्जाम्स और असेसमेंट्स एंड ये सारे मसाइल बताए थे आपने उनको?
मैम मैंने जस्ट उनको एडमिशन को बताया था और कहा था कि मुझे इस मार्च तक जो है मुझे चाहिए, तो उन्होंने मुझे ऐसा कहा कि आप न्यू सेमेस्टर से अप्लाई कर लें।
देखो,
जो
मुझे मेरा मकसद ये था कि आपके एग्जाम्स अच्छे हो जाएं, आपको फेब का महीना मिल जाए, ठीक है ना? ये एग्जाम्स तक महीना या 2 महीने जो भी है, तो अपना पूरा केस प्रॉपरली प्रेजेंट करते हैं ना, फिर उसके मुताबिक आपके चांसेस होते हैं कि यू गेट इट। आपने पूरा नहीं ना लिखा उसमें कि क्यों
मैम
आप
मैंने वो
लेना चाह रहे हो, दैट्स द थिंग।
जो
अच्छा,
हेड है मैंने उनको ईमेल किया हुआ है, उनकी तरफ
हेड
से कल
कौन
उनको
है?
reply,
कौन से हेड?
क्या है दाऊद सर,
हारून दाऊद?
हारून दाऊद।
तो अगर उनका रिप्लाई नहीं आया तो यू शुड फॉलो इट अप ना। उनको पूरी डिटेल लिखी है।
उनको मैंने बताया, मैंने से मुझे चाहिए और मुझे सिर्फ 1 मंथ के लिए चाहिए। इंटरनेट का इशू दिखा है मैम, बाकी तो मैंने कुछ नहीं लिखा।
एक और ईमेल कर दो फॉलो अप में, आप देख लो ना आप।
मैम मैम आज भी कर दूंगा।
हाँ, और पूरी डिटेल उसमें लिखो कि क्यों
हम्म,
आपको रिक्वेस्ट ये अर्जेंट चाहिए। ठीक है।
ओके मैम, ओके मैम।
वासिल, आप कैसे हो?
Fine, ma'am. Good.
आप कहाँ पे हो?
Ma'am, hostel में FC.
एफसी के
Uh,
हॉस्टल में हो?
हाँ जी।
आपको तो कोई इशू नहीं है?
No, ma'am. No, no issue.
आपका सब कुछ ठीक चल रहा है?
Yes, ma'am. Completely fine.
आप सीनियर स्टूडेंट हो?
मैम मेरा 5th सेमेस्टर है।
5th सेमेस्टर?
हाँ
अच्छा,
जी मैम।
ठीक है। अच्छा, ये कहाँ है आपके बाकी दोस्त? ये मुझे कोई नजर नहीं आ रहा है इस वक्त। किधर गए ये
मैम
लोग?
सरफराज की शायद ग्रैंड मदर की तबीयत खराब थी, वो शायद
ओहो,
हॉस्पिटल में।
सरफराज ने भी देनी थी प्रेजेंटेशन, उसकी रहती है और किसकी रहती है? हसनैन। हसनैन का है। हसनैन वैसे भी बहुत कम कम आता
यस।
है ना? तो चलो फिर हम शुरू करते हैं, आप शुरू करो वासिफ।
ओके मैम। So good evening, good morning, everyone. My name is Wasil Buledi, and my topic for presentation is nuclear astrophysics. So I have tried to keep it simple for every person to understand simply. So we're moving on to the next slide. This is the ground information about what nuclear astrophysics is. It is a combination of two fields of physics, in the nuclear physics and astrophysics. Nuclear physics is basically the physics of the small, means that the physics of elementary particles that made up of our reality, the elementary particles like electrons, quarks, and protons, neutrons, the nucleus of an atom, and their properties, and everything that basically uh, goes on that scale is what we study in nuclear physics. And astrophysics is what deals with the study of the heavenly bodies that
जस्ट अ मोमेंट, ये किसके फोन के बीच में आवाज आ रही है?
सॉरी मैम, ये शायद मेरा है
आप
व्हाट्सएप
जरा
में।
उसको साइलेंट कर दो।
यस मैम। डन मैम, शुड आई कंटिन्यू?
यस प्लीज।
So now astrophysics is the physics of everything that the universe is made of. For example, in our universe, there are many phenomena happening around, like the formation of stars, formation of galaxies, and the chemical composition of stars, what they are made of, and what they can produce, and the effects of gravity on matter, and the concept of light, and time. Is all we study in astrophysics, because the astrophysics is the physics of cosmos, as I have said earlier. So in cosmos, in our universe, everything that goes around, everything that's happening is what we study in astrophysics. So I'll be moving on to the next slide. Is now we have come to nuclear astrophysics. So what we study in nuclear astrophysics is mainly what but means that, for example, there are stars. So in the beginning, there were no heavier elements that are present today. For example, iron is the heaviest element. So where these come from is what we study in nuclear astrophysics. For example, uh, stars, star formation, and the core of a star. I will explain further in the next slides how these stars manufacture these heavier elements in their cores. So another Another thing that we study in nuclear astrophysics is the fundamental properties of matter, how matter interacts with each other, and the gravitational effects on matter, and the energy that was created at the moment of the Big Bang, since when our universe was started, and time itself, and the space-time continuum. So, how energy transformed into matter that we see today, and the dark matter which we don't actually see and observe, but its effects can be observed. So all this we
Basil, we cannot hear you.
studying everyone. Everyone might be familiar with the Big Bang Theory concept, that all of the universe that we observe today, that we see today, has come from a point small than a point of a pin. So all the energy, all the matter, everything in the universe was condensed, was has came from a point so dense that even light cannot escape it. Uh, from the point where all the energies, all the matters were similarly just one thing, all come from a single singularity. Many scientists believe that Big Bang is actually not the beginning, have not the beginning, but the transformation of another universe. So what they say is, for example, now we see in our universe there are plenty of black holes around. So it is a general understanding of black holes that there might be that these black holes might be gateways to other universes, but this theory has not been proved that black holes can be the gateways to other universes, but it's there. The people are talking about it. Another concept at the Big Bang, the very concept of time, the time, space time are both are the same thing. Space and time cannot go individually. Space and time are just one thing. For example, it is the fabric of space-time that gives its name. For formation of photons, light particles in the early universe. Here we can see a picture of animated Big Bang. So the universe, our universe is 13.8 billion years old. So if in the beginning there was only a light particles, there were only light particles, subatomic particles, elementary particles that were roaming around the universe, and slowly and gradually the universe expanded and cooled with time, and all the photons through an asymmetry, the photons were converted into matter antimatter, like matter antimatter pairs that later on became the matter that we see today. So uh, at the moment of the Big Bang, the temperatures were so high that that now that all the forces that we see today, all the laws of physics that we understand today were not clear, were unified, because the temperatures were so high, and their effects cannot be manipulated. And also, the Big Bang is the Big Bang theory is mostly considered about right for because we run computer simulations from where the point is, from where the universe is today. The simulations, what the simulations do is they go back in time. They rewind the cosmos, and all the cosmos comes to a single point where from where it all started. So it is right theory at the moment, the Big Bang, uh, for the universe to have created itself from nothing. Or so, yeah. Moving on to the next slide, expanding and evolving universe. So, how did we know that the universe was expanding? So, Edwin Hubble, the scientist who calculated, who found out the universe was expanding, was through his experiment. He was looking for galaxies. He was finding out the distance between galaxies, and what he noticed that some galaxies have had the redshift, and it is called the Doppler effect, through which we can measure the distance between objects, and we find out that if they are moving away from us or coming close to us. What he found out that most of the galaxies were redshifted, means they were moving away from the Earth, moving away from us, and he calculated a relationship between the distance. This relationship, c is the speed of light, is approximately equal to h and d. H is the Hubble constant, which he found out by looking at the galaxy, and d is the distance between the observation site and the galaxy, and galaxies or stars or anything. So what he found out that most of the galaxies, as described in this graph, these dots are the galaxies. This is from the beginning. In the beginning, the galaxies were closely packed together, and with the time passing, and their velocities increased with time, and the distance multiplied with time. So, as you can see, the galaxies are moving away and away from each other. So, the uncertainty in the Hubble value, that at the moment when Hubble found out, he was not completely sure what the uncertainty was, how it came in place. So further, as the science developed, the methods and tools of science improved, we found out that there were effects that the effects were observed, but uh, their source was not their source was not visible, or we cannot even observe, we cannot even measure them, we cannot even we only observe their effects through our machinery, through our equipment. So the increase in the expansion rate due to unknown cause is what is caused. They are called the dark matter or the dark energy. The dark energy is what is causing the universe expand faster. The universe was expanding earlier through its initial velocity, but it has been accelerated further. So accelerated further that it has exceeded the speed of light. The universe is expanding infinitely into something we don't know yet. So the Hubble's calculation found out the universe, that the galaxies were receding away from us at a constant rate, which he calculated as 67 kilometers per second per megaparsec. 1 megaparsec is 3.26 million light years. So light years is the distance the light travels in 1 year. So yeah, he found out this value, but it has been observed lately that the universe is expanding into further infinite universe that we cannot understand yet, and why it has been accelerated. Moving on to the next slide, we have the photons. How the photons in the early universe created the matter that we see today, and the antimatter, or what we can say is the dark matter, or the things that we don't observe. It can be matter or anything we don't know yet. We just give it a name, antimatter. So what happened was, when the universe was just a baby, in the early stages, there was only light, the photon particles. So what happened was the photons on their own annihilated a scattering of photon. They scattered into matter and antimatter particle pairs and annihilate back to the photon. So these processes were being done on their own. So what happened was an asymmetry happened. So when a photon scattered into matter-antimatter particle pair, it couldn't annihilate back into a photon. Then nobody knows why this happened, but it happened. So this symmetry. So what happened was the billions of photons converted into matter-antimatter particle pairs and uh, annihilated back to the photon. So slowly and gradually, what happened was that to every billion antimatter particle, billion and one matter particles came out. So this symmetry is, we can say, it is small, but considering the size of the universe, it was large, and it happened. And what the matter we see today is the aftermath of that asymmetry. For every billion antimatter particle, billion and one matter particles formed. So this asymmetry made, we can say that this asymmetry made us. We are made of matter, and the particles that came afterwards. So next is the speed of light. The speed of light is considered to be a cosmic barrier for the universe that we understand today. No matter can exceed this limit. Uh, uh, the energy and matter are related to each other, but no matter can exceed the speed of light. It is the cosmic barrier, as it is written here. So speed of light is a core concept in understanding the ways of the universe, how it has expanded and evolved throughout the time. Light is a very tricky concept, as everybody understands that what we see today is the reflection of light that reaches our eyes. So when we observe the cosmos, what we see today, for example, we are looking out in the universe through a telescope. What we see today is mm, we see in the past. We see in the past, for example, as the light from the stars, from the galaxies, from the neutron stars, it takes time to reach us. So, in a way, it is considered to be time travel. What we see, is the past, is not the present. So it is a nice concept of light. So moving on, early conditions of the universe. So when the universe was formed, it it came from a point so infinitesimally small that all the laws of physics were unified. Now we can formulate, and we can distinguish between the quantum physics and the relativity physics of the large and physics of the small, and anything that goes around there. But at the moment the universe was formed, there were no laws of physics working. It was just a soup of uh, hot soup of elementary particles moving around here and there. Extreme temperatures were observed, and the temperatures were so high, nothing could be happened. So in the graph we can see uh, end of inflation. Inflation is a period where the universe cooled dramatically from high temperatures to somewhat lower degrees. Formation after 10 seconds of the formation of the universe, the formation of deuterium and helium gases, uh, and 1 month after CMB is the cosmic microwave background that we are going to explain further in the coming slides. And 10,000 years after, radiation and matter conversion was happening at temperatures 20,000 kelvins, and the last scattering of cosmic microwave background at 300,000 years after the end of inflation. So these effects can be observed through various telescopes that we can today. So we have found out that the universe had a rough beginning, a hot beginning. Uh, so yeah, moving on to the next slide is the cosmic inflation. Cosmic inflation is the expansion of the universe that was faster than light itself. Uh, why it is faster than light? As I have said earlier, that the speed of light is the cosmic barrier for everything in the universe, not the universe itself. The universe can expand faster, but anything in the universe cannot exceed the speed of light limit. So this is what happened. Expansion faster than light happened. Instant drop of temperatures from 10 to power 32 degrees Kelvin to 10 to power 28. Flat uni the Einstein's general theory of relativity suggests that the universe having mass, as the general theory of relativity says, the mass converts. Mass has effects on gravity. Mass can have a positive or a negative curvature in the space-time continuum. But what the inflation theory says that the universe is flat, and we have observed a flat universe. So the reason for inflation may be weakening of the speed of light. So what do we mean by that weakening of speed of light? We haven't measured the weakening of speed of light, but what the scientists believe that the speed of light in the inflation period may be inflation due to the speed of light. This is what explains the inflation period, the dramatic change, the dramatic decrease in the temperatures of the universe. These all can be explained if we weaken the speed of light. Maybe it's weakening today even, but we can't observe, we can measure it in our equipments right now. But this may be a point, this may be a theory. This is a theory, but it is not formulated, it is not completely understood, it is not completely uh, proved right. So as we cannot measure it, that's the main reason for it. So the inflation happened, universe expanded faster than light, and temperatures dropped dramatically, proved the universe is flat. So speed of light. Moving on. This is the cosmic microwave background. This map, as you can see here, is these are the colors determine the temperature is minus 200 microkelvin to 200 microkelvin. So what cosmic microwave background is actually is the radiation from the birth of the universe, radiation from leftover radiation after the Big Bang happened. So when the universe was just forming, just came into place, the temperatures were so high, uh, uh, there were only elementary particles surviving. So it is very important in understanding what our universe is, how it is evolving, how in what thing it is expanding into. So these cosmic microwave background, it is important in understanding the universe that we live in today, and the universe that we are the universe finding itself out. So so yeah, cosmic microwave background is the important concept in the field of nuclear astrophysics, as it says important fundamental uh, areas of astrophysics, of the expansion of the universe itself, how the universe behaves under extreme temperatures. And so moving on, this matter and energy relation. The equation E equals mc square is rather simple, but it's most important equation to my view. it says that energy can be converted into matter and vice versa. For giving that matter can matter when matter travels at the speed of light, it converts into energy, and when energy's speed is somehow decreased, it can convert into matter. So Einstein gave up this equation, and so nuclear reaction in the stars. Stars are like our sun and the heavenly bodies, other stars. They regularly, frequently convert matter into energy through fusion, and fission reactions. Here in the picture, we have gold atoms moving approximately near to the speed of light. So we have this is the gamma radiation. This is this is the radiation that can convert it into matter. This gold atom can be converted into energy. This is what it's saying. Moving on to next slide, formation of stars and galaxies. So when the universe cooled down, expanding further and further and evolving, so what happened was, uh, now that the asymmetry has created matter particles, they are spread throughout the universe, throughout the cosmos, ununiformly here and there. So what happened was that uh, where there were more gases and particles, the gravity had its effects, and gravity came bring them all together to form first generations of stars. When they collided with each other, the primordial nucleosynthesis happened. The first nuclear reactions started to happening. The elementary particles started interacting with each other, creating nuclear fusion reactions. They fused and they formed stars. What we see today in the cosmic microwave background, observed as stars, first generation of stars in galaxies. Uh, and the star clusters were formed and galaxies were birthed, first generations. So all this can we observe in the cosmic microwave background. These radiations tell us that there were these stars that firstly formed in the galaxies, that the stars came together and formed the galaxies. So this is a small video animation video that tells about the universe, formation of stars. As in the video, we saw that how the stars, these gas clouds will will eventually will be made, will be converted into stars when they fuse together, when they come together. So moving on to the next slide, we have a stellar nucleosynthesis. So stellar nucleosynthesis is what the stars manufacture in their cores. As everybody knows that in the core of a star, nuclear reactions are happening. day in, day out. So what they do is they with every reaction, elements are formed. Heavier elements like gold, iron is the heaviest iron, and every element that we see today has manufactured, has formed in the core of a star. At the very atoms that we made of, the very elements that that we need to stay alive. For example, oxygen, carbon. Carbon is the abundant element in the universe. So all these elements were formed in the cores of stars. So we can say that these stars are the kitchens of the universe. So they create stuff, they create elements to further support the life that we see today. So how these particles, how these elements, not particles, elements, how these elements spread. So in the later years, when the star, everything has to age, everything has to die. Same goes for the stars. So what happens is that when stars have run out of their fuel to burn to support the fusion and fusion nuclear reactions, what they do, they collapse on their own weight under the influence of gravity. They collapse and then they explode. And well, this is what a supernova is. An explosion of a heavy star, and what it does is it spreads the elements that were formed inside the star throughout the region where it exploded. So after explosion, these elements the elements are formed into a gas cloud, which under the influence of gravity will form another generation of stars and planets that like our own, like our sun has been made of, and the planets and everything in it. And for example, on Earth, everything that we see today, every life form, every element, every anything was formed in the core of once star that was here in the place of our solar system. So now there is another video illustration of how these elements are formed. So firstly, it's hydrogen, then goes further back in helium. The temperatures rise, then is carbon, then is neon, oxygen, silicon, and iron. So all these elements that we saw there, hydrogen, helium, neon, carbon, oxygen, these are fundamental elements that life needs to be able to live. So without these elements, there would be no us. So it's very important in the evolution of the universe and evolution of the species and life forms that we see today. So moving on is the chronology of the known
Just a
universe.
moment, beta. The meeting is going to end, so I would like you all to disconnect and connect again using the same link. Okay, then we can continue with this. Okay.